vast universe? That challenging question has been reignited once again as Mars continuously reveals surprising new mysteries. Strange rocks, clues about water, and special chemical compositions. All are gradually revealing where life might be hiding on Mars. The strange rock leads to clues about life on Mars. From a normal panoramic photo of a rock, deeper questions have been raised. Did Mars once contain life? And are these strange phenomena traces of a forgotten past or signals of something greater? NASA's Perseverance rover has just sent back a discovery that stirred public opinion. A rock with a peculiar shape located at the edge of the Jezero Crater, where water was believed to have existed in the distant past of the Red Planet. Bingstein Pow. Overall, the rock has a bizarre appearance and is not easily confused with any known geological type. From a distance, the rock looks like a giant sponge with a pitted surface like an ant nest, covered with dense nodules and rounded, oval protrusions. Some nodules have broken open, revealing an internal structure resembling a cracked shell. This image immediately sparked curiosity not only among scientists but also the online community, with some commenting that it looks like a nest or even some living object that once existed or landed there. These imaginative interpretations are not without reason, as one of the biggest goals of Mars missions has long been to determine whether this planet ever hosted life. Although no direct evidence of life on Mars has been found to date, the discovery of liquid water in the past, as well as the presence of methane, an organic compound related to biological processes, has kept scientists continuously searching for clues. And accordingly, images like this rock's only raise more questions and new hypotheses. When analyzing the rock's peculiar shape more deeply, scientists proposed several possibilities based on known natural phenomena on Earth. One of the most popular hypotheses suggests that the nodules and protrusions of the rock are the result of mineral precipitation in the presence of liquid water. Specifically, when water that existed on Mars billions of years ago seeped through cracks in the rock, minerals in the water could settle and concentrate around a small nucleus, gradually forming prominent nodules on the rock's surface. This is a common process in wet geological environments, such as mineral springs or ancient sediments on Earth, where chemical conditions allow the formation of similar structures. Additionally, some researchers do not rule out the possibility that this rock could have a biological origin. On Earth, nodules formed by bacterial activity through biomineralization have been discovered. In this process, microorganisms promote the precipitation of metal compounds like oxides, forming structures similar to nuclei on rock surfaces. Finding a similar structure on Mars, in an environment that once had water, opens up the possibility that microbial life may have existed and left traces in the geological structure. Another hypothesis being considered is that these strange nodules formed after the cooling and crystallization of high-temperature materials following volcanic eruptions or celestial impacts. In the harsh environment of Mars, extreme geological disturbances that occurred could create unusual rock structures, and this rock might be the product of one such event. Nevertheless, to reach a definitive conclusion about the rock's origin, direct analysis of rock samples is necessary. However, due to technical limitations and the vast distance, scientists currently cannot collect physical samples from this rock and bring them back to Earth for detailed laboratory testing. Therefore, all current assessments remain at the level of speculation based on images and remotely collected data. Although the true nature of the rock cannot yet be determined, this discovery once again emphasizes the importance and value of Mars exploration missions. Since landing on the Red Planet in 2021, the Perseverance rover has continuously captured valuable images, conducted scientific experiments, measured climate and terrain, and searched for prebiotic evidence. The Jezero Crater area, where Perseverance is currently operating, was once an ancient lake and is now one of the most promising sites for finding traces of life. Geological history but also opens new questions for scientists about processes that occurred in the planet. Continuing research, developing technology, and investing in space exploration is the only way to find answers to these mysteries. In the near future, with joint efforts from the international scientific community and aerospace organizations, we may have more accurate answers. By firing lasers at Martian rocks, NASA's rover finds clues to life. The Green Warrior searching for life, NASA's Perseverance, fired lasers at rocks in the Jezero Crater area, where scientists suspect a giant ice sheet once existed, and it found clues. According to Science and Earth, the targeted rocks stand out with a strangely pale color, lying only on the Martian surface, not matching the surrounding environment. They are called float rocks and are believed to have come from elsewhere, transported to their current location by water flow, weathering and erosion processes. The Perseverance operations team directed this autonomous rover to use the laser-induced breakdown spectroscopy device. The emitted laser pulses vaporize a small amount of minerals in the rock and excite it. Then, the spectrometer studies the light emitted from atoms and ions in the mineral vapor as they return to their ground state to see what elements those atoms and ions contain. The result was a big surprise. These rocks are very different from anything we've seen on Mars before. The main component of the rock is a mineral called kaolinite, a soft white silica mineral. Kaolinite on Mars is slightly different from kaolinite on Earth, significantly harder, possibly due to different weathering conditions. But importantly, kaolinite requires moist, temperate conditions to form, which are also favorable conditions for some forms of bacteria to survive. Researchers also identified a mineral called spinel, a type of mafic gemstone common on Earth, mixed within the kaolinite. But overall, this composition shows that water once existed on the Red Planet, because without water, the existence of the above components would be illogical. Therefore, this new research further confirms NASA's belief that Mars once had many oceans and rivers similar to Earth around 3 billion years ago. In another development, NASA's Curiosity rover has found the largest organic compound ever encountered on Mars, strengthening the hypothesis that life appeared on the Red Planet billions of years ago. A newly discovered compound in a 3.7 billion-year-old rock sample collected at Yellowknife, an ancient lakebed on Mars, contains all the necessary ingredients for life during the planet's wetter and warmer past. Tests on the rover indicate the rock sample contains long-chain organic molecules believed to be traces of fatty acids. They could be created by chemical reactions but are key components of cell membranes in all living organisms on Earth. If we have long-chain fatty acids on Mars, one hypothesis is they came from the decomposition of cell membranes 3.7 billion years ago. Discovery of evidence of liquid water on Mars. NASA's Curiosity rover has captured images of remnants of ripples in an ancient lakebed on Mars, showing liquid water once interacted with the atmosphere in shallow ancient lakes on Mars. This discovery is evidence that not all water on the red planet was ice-covered, as some Martian climate models suggest. Planetary geologists and Mars astronomers have known for decades that water may have once been present on the planet. After the mission, NASA's Mariner 9 captured images of dry river valleys in the 1970s, but there is still debate about the form of water and its duration. Some models predict that any liquid water on the Martian surface must have been covered by ice layers before it disappeared. However, new findings published in the journal Science tell a different story. The patterns captured by NASA's Curiosity rover are called ripples, small wave-like structures formed along the shores of the lake bed. This means liquid water must have flowed across the Martian surface at some point in its history. The ripples appear in two separate lake beds in Jezero Crater, where Curiosity has been exploring since August 2012. The shape of these ripples could only form underwater, exposed to the atmosphere and affected by wind. Researchers also analyzed the height and spacing of the ripple waves to determine the size of the lake that formed them. These structures are about 6 millimeters high and spaced about 4 to 5 centimeters apart, indicating they were created by small waves. Based on these dimensions, researchers believe the lake on Mars must have been less than 2 meters deep. Both dry lake beds appear to have formed about 3.7 billion years ago, suggesting Mars had a thick atmosphere and was warm enough to support liquid water. For a longer period than previously thought, this could have interesting implications.
Extending the presence of liquid water would expand the habitability potential for microbes later in Martian history.
In other words, living organisms might have had a longer period during which they could evolve on Mars. Discovery of a lichen species
Capable of surviving on Mars.
in an unexpected breakthrough in the field of astrobiology and research on extraterrestrial life viability.
Polish scientists have announced a discovery that forces the international scientific community to reconsider many previous assumptions about survival capabilities on Mars.
According to a new study published in the scientific journal IMA Fungus, two lichen species, a unique symbiotic form of fungi and algae or cyanobacteria, were exposed to simulated Martian surface conditions for 5 hours. And one of them showed remarkable resilience, even maintaining biological activity throughout the testing process. This study not only expands human understanding of biological limits under extreme conditions, but also opens up the potential of using Earth organisms to support future space exploration missions. The two lichen species used in the study were Diplodocida micrum and Catora acurita. These are two typical representatives of organisms found in extreme environments on Earth, such as frigid tundra regions or arid deserts, where most other life forms struggle to survive.
Lichens have long been known for their special survival abilities, thanks to the tight symbiotic structure between fungi and photosynthetic microorganisms.
However, that a lichen species
can maintain living activity under simulated Martian conditions.
with low atmospheric pressure, extreme temperatures, and high ionizing radiation levels is something few previously anticipated. During testing, researchers meticulously recreated conditions on the Martian surface, including extremely low air pressure, freezing temperatures, and particularly radiation intensity equivalent to 1 year of strong solar activity on the red planet. The results were surprising when Diplodocida micrum, one species, not only wasn't severely damaged but also maintained metabolic processes. A clear indicator that this organism remains active and consumes energy, meaning it's alive and can perform essential biological functions. Meanwhile, the other lichen species, Catura acurita, showed less resilience and didn't achieve the same level of maintained biological activity as Diplodocida micron. Lead author of the study, Dr. Kaya Sarkabala, shared that this is the first study where we've observed fungal partners in lichen symbiosis can maintain biological activity under near Martian surface conditions. She emphasized that maintaining metabolic processes and activating defense mechanisms are strong signs that Diplodocida micron has superior adaptability that suggests potential for life surviving in extraterrestrial environments, at least at the microbial level. Sarkabala also noted that this finding forces the scientific community to reconsider the long-held assumption that ionizing radiation on Mars is an insurmountable barrier to life. This shows that under certain conditions and with special organisms, life can still flourish even in the most extreme environments. Notable for the study is the role of water, a vital element for all known life forms. The tested organisms here were hydrated, meaning they still contain sufficient moisture to maintain biological functions when exposed to simulated Martian environment. According to Sarkabala, understanding how these organisms respond to ionizing radiation while still hydrated provides insights into their actual survival capabilities in long-term space missions. This is particularly important because if an organism can survive under such conditions, it could be included in research missions to observe long-term responses, or even support building artificial ecosystems for humans in the future. This study has opened a new door for rethinking the concept of habitability in extraterrestrial environments. If an organism can not only survive but function normally in a Mars-like simulated environment, there might be other extreme life forms, yet undiscovered, waiting to be found somewhere in the universe. Meanwhile, organisms like lichens could also become useful tools in future space missions, such as helping generate oxygen, process biological waste, or serve as functional food sources in closed ecosystems. Additionally, this study also reflects a clear trend in planetary science. More researchers are focusing on Earth organisms' adaptability to extreme conditions, aiming to determine the limits of life and find feasible strategies for exploring or even settling extraterrestrially. Using resilient organisms like lichens and testing them in harsh environments not only helps us understand life more deeply but also supports the design of suitable technology to sustain life in the future, both on our climate-changing Earth and in outer space environments. While Mars exploration plans are still being implemented and extraterrestrial life support technology is developing, the new discovery about lichens brings positive signals that life, even in its simplest form, can overcome seemingly impossible conditions. And if lichens can do that, who knows what the true limits of biology are? Perhaps in the near future, these small but persistent symbiotic organisms will be the first pioneers from Earth to set foot on the red planet. New discovery about Mars beaches and colors. We may have misunderstood the red color of Martian dust, and this planet once had beautiful beaches surrounding ancient oceans, potentially hosting life. A new study reveals that the red color in Martian dust formed from chemical reactions in wet conditions rather than dry ones, which could affect the possibility of life on the red planet. Mars is rich in iron and appears red due to iron oxidation, spread by wind and adhering to dust particles on the planet over billions of years. Through observations from previous spacecraft, scientists believe that oxidation occurred under arid conditions when water on Mars had disappeared. However, the new study in Nature Communications refutes this argument. The research team used advanced grinding machines to create realistic replicas of Martian dust in Earth laboratories. They then analyzed this dust using methods similar to those performed on spacecraft. The team found that Mars' red color matches ferrihydrite, a water containing iron oxide, and suggests this red hue formed when Mars still had oceans. In other words, Mars is red today because it was once blue in the past. This discovery raises new questions about Mars. The study also indicates that Mars went through different periods with cold, wet conditions and chemical reactions before becoming the desert it is today. This could help scientists more accurately estimate the time frame when life might have existed on Mars, while identifying potential environments where bacteria could thrive.
Mars still holds deep mysteries, challenging humanity's intelligence and desire for exploration.
Each new discovery is an important
Piece in a complete picture of the red planet's past and future.
Could Mars have hosted life before Earth? Has any life, even just tiny bacteria, ever existed or still exists there? The journey to find answers is still long, but with the continuous advancement of science and technology and humanity's spirit of space conquest, we have the right to hope that in the near future, Mars' secrets will be revealed, opening a new era of extraterrestrial life.